Hello and welcome to Industry Outlook Expert Panel. On the demand of our readers, we have come up with this special webinar on the adoption of robotics and automation in manufacturing. The integration of robotics and automation is driving efficiency, precision, and innovation in manufacturing processes, promising to revolutionize the industry as we know it. Today, our distinguished panel of experts will delve into the core aspects of adopting robotics and automation, offering valuable insights and perspectives. We will explore the benefits, challenges, and real-world applications of these technologies, drawing from the experiences and expertise of our distinguished speakers. You will have the opportunity to gain a deeper understanding of how robotics and automation are transforming manufacturing and how your organization can leverage these advancements to stay competitive in this ever-evolving market. So let's dive into the world of robotics and automation in manufacturing. On the panel today, we have some esteemed guests from different industries who will share their views on the adoption of robotics and automation in manufacturing. So without any further ado, let me invite Ms. Sirisha to share her views on the adoption of robotics and automation in automotive industry. Over to you, Ms. Sirisha.
Thank you so much. Thank you, audience. So what this panel we intend to do would be, we are going to talk about from three different sectors. I'm coming from Continental Automotive, so I'm going to focus a little more about examples of robotics and automation, what we have done in Continental, where we believe that can be easily implemented. So my approach would be, in the next 10 minutes of my presentation, I will cover about what are the technologies and what are the easiest ways to implement. So hopefully that will be helpful as a takeaway. What I intend to do would be to start off a little journey of Industry 4.0, particularly talk about some use cases which I think could be relevant for any industry. So that would be my presentation in the next 10 minutes. To start up, when we talk about automation, the first thing comes to anyone's mind would be, what was the past and where are we heading to? So Industry 4.0 for sure is a buzzword now with a lot of technologies. So particularly if I look at what all should an Industry 4.0 cover, we are talking about simulation, we are talking about robotics, big data, additive manufacturing, cybersecurity, which is a trend now, and IoT. Yeah, these are the some elements which I'm going to cover the use cases today. When we talk about we want to implement, the main purpose why anyone wants to implement automation, the way I would look at it would be, it should be database decision making. That's the primary purpose. And at the end of it, what does the industry want? That is to leverage the quality, reduce the waste. These are the two purposes. Now, how do we go about planning for robotics and automation? One is, the way we have to look at is what is the objective and what is the vision. Are we in line with this when we want to implement? That would be the first thing we want to look at it, and identify the areas of improvement. Sometimes the question comes, should we be even roll out a lot of automation because we want to be in par with every other industry, or is there a need based implementation? So the answer, the way I would look at it would be, identify opportunities of improvement and then go ahead for the implementation. Second, prioritize the low hanging fruits. It is for sure good to have a lot of automation done, but then how do we start would be, start with the low hanging fruits. Also look at the ROI of it, if not for the 100% automation. Then the last thing would be, monitor the efficiency of improvement and then scale it up further. So this is the way the planning phase of Industry 4.0 and automation could be to start off with. Now we can see a lot of levels of automation. Start with a basic automation, go with an automated assembly lines. For sure, we have to have data collection and the connected machines. And the last would be an advanced way of automation, including robots, AGVs, smart glasses, complete connectivity in terms of cloud connectivity or connected machines. So that would be where we can go step by step in terms of scale up. Now, key benefits, not to go in detail, but why do we even do automation would be, one is availability has to improve. and then productivity will improve. So these are some facts and figures what we have shown on the screen. This is exactly where we were able to achieve with automation. Material cost improvement, maintenance cost improvement in the tune of say 20 to 35%, and manpower improvement is what we have seen, operational efficiency. So these are the elements what we see is set as a benefit of the automation and robotics. So with this pre-introduction, I would like to just show a couple of examples on what are the areas we have implemented. One is in terms of collaborative robots and AGVs. This is one set of advanced robotics what we have implemented. And the bigger chunk is MES. When we talk about MES, there are different levels of MES implementation every organization does. Big data is something which everyone is trying to analyze, but what are the key areas which definitely every organization can look at would be use the big data and have a trend to verify is the OE improving, and are we seeing the quality improvement in terms of first pass yield, is the process stable. These are the key elements which we can actually use the MES data for. And for sure, the last element would be we want to achieve the quality at the same time downtime reduction, in turn the overall operational efficiency. Some examples would be in terms of automation. RP is a quick example. You can see on my right side of the screen a lot of examples on what all areas we can do automation. It could be HR, it could be finance, or supply chain as well. And some more examples, starting with supply chain to shop floor management, be it variables, and also in the maintenance we can go for. Yeah, so with this, I would like to conclude my presentation.
Thank you so much for sharing your insights, Ms. Sirisha. I would now like to invite Mr. Zurvan to share his thoughts from the furniture industry perspective.
Good morning to my co-panelists and all the participants. I think Sirisha has given us a good foundation on which we can discuss automation and Industry 4.0. So let me start by talking a little bit about the furniture industry, which today is in a way I would still call a highly fragmented industry. Though it has consolidated a bit over the last decade, it is still highly fragmented. And you'll be surprised that still at least about 75 to 80% of the manufacturing in terms of the products that we get are from the unorganized sector. I mean, that's a huge thing. Largely with the carpenter base, the small, operators, and the very small enterprise. Then you have the handicraft also, which comes into furniture. So it's a very mixed bag, and that is something that has to be borne in mind as a background to what I'm about to talk about. In general, the integration of automation into an existing supply chain and manufacturing system, and more so where furniture is concerned, can be a disruptive process that demands significant adjustments. And that's a little bit about what I'm going to talk. Because if you do not get seamless integration, then the cure becomes worse than the ailment which we are out to address in the first place. So having said that, what are the three key hurdles for the furniture industry, which I would consider to be, the deciding ones and important ones, which need to be addressed? First and foremost, furniture is not a mass production line, as we really think. For those who are outside the industry, I need to say this. At the same time, furniture faces competition from products that come from, well, China and other parts of the eastern part of the world, where they do mass production, supply it here in mixed containers, and therefore they get certain price advantages because they supply similar products to a vast variety of customers, not only to India, but across the globe. So they get the benefits of scale. And one of the challenges of the furniture industry here is to be able to compete at that scale or show the customer value. Why our goods should cost more because of certain factors of durability and customization and ability. So furniture is a bit of a tricky business where that is concerned. So the volume to variety ratio is adverse when it comes to manufacturing furniture on a higher scale. For a small enterprise, anyway, he's going flat out, so it really doesn't matter. So one of the areas of challenge is the volume variety ratio. The second area of challenge is when one wants to go into automation and robotics, one has to do a huge amount of codification. Okay, that is steps in digitization. Now that again becomes a major challenge when you have a very high number of SKUs, as we call it, stock keeping units. Okay, not only that, it's the fact that the actual manufacturing cycle when one is making factory made furniture is a very short one. So one cannot do new codification for every new product, because then the codification will take longer than the manufacturing itself. So these are the challenges. I'll come to the solutions also. I mean, because obviously we have spent enough and more time in it, and we have made certain progresses in it. The third one, which has also come up in the questions which you gave, is material consistency. Now, I think the government has taken a right stand in starting to work very strongly on the Biesse standards of incoming material and the standards to be maintained on RM. But still, automation requires a far stringent level of consistency. Let me explain. If one has to use robotics in something like bending, a very simple process, sheet metal bending, okay, the flatness of the material plays a critical role, because when the robot moves the material across, if the material is not flat, it will crash. And we have these kind of very expensive incidences which really set us back substantially. So we have to go back to the material manufacturer, to the steel sheet metal manufacturer, and talk about stretch leveling and how they can help by giving flatter material. And we work on that. Similarly, since we've got Biesse here, I can talk about inconsistency in the particle boards. Okay. When one wants to use a high quality diamond cutter, what do you have? You'll have a nail coming into the particle board, which will break the whole thing and set you back for you've got to do a lot of resetting and recalibration that it needs to be done. Okay. So you get all kinds of junk coming in, into that. So these are inconsistencies that need to be dealt with, and these are what give us certain challenges. Now, there is this one question about why automation. And I think Sirisha did touch upon it, but I would like to put a different angle to it. At the end of the day, let's understand one thing. Why are we in business? Or what is it that we need to do? And I think we cannot lose sight of the fact that it's all to do with the customer. What does the customer want? And how do we give the customer what they want in the most cost-effective way, best quality, value for money, in the minimum time? Quality, delivery, cost. This is what the customer wants. At the same time, if everybody is providing that, how do we anticipate the need of the customer? That's where big data comes in, and provide the customer what he hasn't even thought of, but would like to have. Okay, addressing the latent needs of the customer.
Thank you, Mr. Zurvan, for the beautiful overview. I would now like to invite Mr. Prahallada to share his views from the machinery manufacturing perspective.
Everybody. Good morning, Sudhakar and the panel discussion members. That was very insightful thoughts. What started with Sirisha, and Of course, Zurvan gave most of the thoughts what I wanted to share. A bit technical, this thing from Biesse, which actually reinforces what Mr. Zurvan told about this appropriate automation. That's the catchword. So I start with the presentation. Is it visible? Can you confirm, please?
Yes.
Yes, please.
Yes.
So I'll go ahead. So Sirisha just mentioned about this. So the various steps that started with this, all of us are aware about this. So today we are in the industry 4.0, this thing with cyber physical systems that are there. And the next catch buzz that is happening is about intelligence 5.0. Later I'll share a slide on this, where BSA is working with our associate partners, especially in integrating AI ML solutions into the present context of Industry 4.0 with advanced sensors. So here, as Zurvan was mentioning, he gave more bonus on the material. Of course, material is the most important thing to handle actually in terms of automation. We have a lot of scope for covering the material here. So on these forums, the basic framework that we start with industrial engineering, of course, today here I focus more on material where there is a lot of scope for continuous improvement, mainly in the optimization of the material what we are using. And Zurvan mentioned clearly that we have issues, a lot of issues that we are facing, and there is tremendous effort that is being done with standardization of panels with institutes like IWST, where we closely work with. So here it's more about the handling systems that what we have with BSA. So I'll introduce, and as Zurvan was mentioning, the thing is this industry, especially the furniture, woodworking industry for that matter, is still in a nascent stage in India, with few exceptions, like of course Interior and some of the companies that have found the way out actually. And it's not even India being exporter of furniture. Nowhere we feature even in top 10. Okay, so there is a lot of scope that actually is there for furniture industry, and it is actually identified as a sunshine industry by Ministry of Commerce. So we just see how well actually we can go with these steps in automation as well as robotics, and what BSA group has got that in offer, particularly in reference to woodworking. We have solutions also in glass working and stone, but today I restrict the information with the woodworking. So we have a separate division called BSA Systems that deals with wood handling equipment, automatic warehousing, loading and unloading systems, primarily for the furniture and construction industries, where we guarantee production with reduced costs. And of course, Zurvan was mentioning time scales are very important, and the promise to the customer, as he was putting it up. Automation to address low value operations like building custom stacks. This is in the supply chain. There we consider this, and moving material parts within the plant. And of course, after finishing or after the secondary processes, what we do, sorting out the parts, part identification, the right part reaching the right customers as per the order. So everything identified. And proudly, we have installed more than 1,000 systems worldwide. We have very few that is installed in India in some projects here. And we have this thing called WinStore, which is actually an automated magazine for optimized management of panels. So it is actually possible to manage multi-sized and multicolored stacks, and it's suitable for large contract manufacturers and case furniture makers. And it guarantees production with reduced times and costs. And it has an integrated software management of the entire system between customers management system and manufacturing process. So the integration part also is taken care. And of course, most of the customers, our customers worldwide, they have realized ROI within 1 year, even though it's a big investment. So when it comes to the handling systems, we have the types called K1, which is the fastest, robust, and flexible for many machines integrated in the same line. And we have the K2 range that is there for medium range for high performance and flexibility for machine cells. And we have the K2 and we have the K3 for entry level and medium level performance and flexibility for monolines. So this is in this thing to see that how well the systems actually suit to the requirements of the customers who are from MSMEs as well as from medium scale enterprises and large scale enterprises that are there into furniture making, mainly the modular furniture. So as it goes up, K1 is the best when it comes to productivity, flexibility, and performance. And of course, the space requirements also increases. And the K3 is actually very compact, which can actually configure to a particular machining cell or a line.
Thank you, Mr. Prahallada, for your comprehensive insights into the market and the adoption of robotics in it. Thank you so much to all our esteemed panelists for their time. I am sure our attendees must have got many key takeaways and actionable insights which they can implement in their respective businesses.